Good morning, everybody. Welcome back to Ons Academy. Lesson 4 Air Pressure Explanation video. This is Standard 7 Subject Geography. Made by Farooq Mohammed from Batan Technical High School, Bandra. Channel's name Ons Academy. Standard 7 Subject Geography. Okay, let's recall. Have you tried the activity that shows air has been given on page 16 of your science textbook? Geographical explanation. During the activity, you saw that the balance tipped on the side of the full ground below. This shows that the air has weight. Anything that has weight exerts pressure on the thing that lies below it. Thus, the air in the atmosphere exerts pressure on the surface of the earth. Due to this, air pressure various phenomena like storms, precipitation, etc. occur in the atmosphere. There are variations in air pressure. Before reading lesson, I would like to tell you like, share, subscribe my channel on Academy. Air pressure is non-uniform on all places on the Earth's surface. Air pressure keeps on changing from time to time. The altitude of a region, temperature of the air, and amount of water vapor in the air are some factors influencing air pressure. Altitude of the region and air pressure. The proportion of dust in the air, water, vapor, heavy gases, etc. is higher in the air closer to the surface of the earth. This proportion decreases with increasing altitude. As one moves higher and higher from the closer water vapor this proportion decreases with increasing altitude surface of the earth. The air becomes thinner and thinner. As a result, the air pressure decreases with increasing altitude, air temperature and air pressure. Okay, try this at your home. Take a flying lantern like here. See here, they have taken a flying lantern, tie and approximately 5-meter long thread to the flying lantern so that can bring the lantern down whenever you require. To tie a 5-meter long thread, so because when the lantern will be flying, so you can bring down the lamp whenever you require. After carefully reading the instructions given on the package of the lantern, open it and light the candle placed in it. Observe what happens. Let's see here. After some time, bring the lantern down with the help of the thread and put out the candle. Okay. Did the flying lantern start ascending immediately after the candle was lit? What would have happened to flying lantern as had the candle got extinguished after the lantern had gone up in the air? Geographical explanation. There in the flying lantern gets heated. Once the candle is lit, The hot air expands. Ex, sorry. The hot air expands, becomes lighter, and starts moving up. Therefore, the lantern is also lifted up towards the sky. In nature, too, a similar phenomenon occurs. Temperature and air pressure are closely related. Wherever the temperature is high, the air pressure is low. As the temperature rises, the air gets heated, expands, and becomes lighter. This lighter air in the vicinity of the Earth's surface starts moving up towards the sky. As a result, the air pressure in such areas decreases. Think about it. What will be the effect on air pressure if the temperature drops? Why? So here I have a diagram: pressure belts and planetary winds, temperature zones. These two diagrams, this and this, make in your notebook and write these names: 90% North Pole, these etc. Temperature zones and pressure belts are interrelated to each other, but the latitudinal extent of the temperature zones is much larger, while pressure belts are narrower. See figure 4.2a and 4.2b. For example, the temperature zone extends from 23 degree 30 degree to 66 degree 30 degree. Compared to this, the air pressure belt has limited extent. It is generally up to 10 parallel. The uncertain distribution of temperature influences the distribution of temperature influences the distribution of air pressure too. This leads to the formation of low and high pressure belts horizontally between the equator and the poles. See figure 4.2b. Which pressure belt is mainly found in the tropics? So these are the some questions. Okay. Pressure belts on the Earth's surface. The heat received from the sun is uneven in different regions, hence the distribution of the temperature is uneven from the equator to the poles. As a result, the temperature zones are created. We have studied this in the previous class. Equatorial low pressure belt. The sun rays can be perpendicular between the Tropic of Cancer and the Tropic of Capricorn, so the temperature is higher in this region. Hence, air is in this region gets heated, expands, becomes lighter, and moves towards in the sky. As this process operates continuously, a low pressure belt gets formed in the central part of this region between the parallels 5% north and 5 degrees south. Mid-latitudinal high pressure belts. The heated air becomes lighter, starts ascending, and after reaching higher altitudes, moves us towards the polar region. I pointing towards the north and the south pole due to low temperatures at the higher altitudes. The air cools down, becomes heavier. This heavier air descends down in both the hemispheres in the region between 25% to 35% parallels. This leads to the formation of high pressure belts in these parallels of latitudes in both of the hemispheres. This air is dry, hence the region does not get rainfall. Consequently, most of the hot deserts on the earth are found in these regions. See figure 4.2b. Subpolar low pressure belts. Due to the earth, earth's curvature, the area between two parallels gets two parallels reduced as we move towards the poles. This results in lesser friction of the air with the Earth's surface. Air in this region is thrown out because of this reduced friction and also because of the Earth's rotational motion. This leads to the development of a low pressure belt. The condition is observed in the area between 55% and 65% parallels in both the hemispheres. Polar high pressure belts. In both the polar regions, the temperature is below 0% Celsius throughout the year. Hence, here the air is cold. As a result, high pressure belts get formed. These are called polar high pressure belts. They generally occupy the area between 80% and 90% parallels in both the hemispheres. The durations and the intensity of sun rays varies during particular periods of the year. In both the hemispheres, as a result, the locations of the temperature zones and the pressure belts dependent on the sun seat also vary. This change is of the order of 5% to 7% towards north in Uttarayan and 5% to 7% south in Dakshinyan. This is called the oscillation of pressure belts. Always remember the major difference between the temperature zones and pressure belts is that the temperature zones are continuous and spread from the equator to the poles. From terry to frigid, pressure belts are not continuous and areas of high and low pressure are found in different regions from the equator to the poles. Effects. What are the effects of these? Air pressure has the following effects: origin of winds, generation of storms, conventional type of rain, isobars. The line that joins the places of equal pressure on the map is called an isobar. This is called isobar. Can you tell? Observe the map given above and study the distribution of air pressure. Consider the following points. These are, can you tell? Okay, we will do after. Use your brain power. If there is low pressure at the equator, that will be the condition of air pressure in the Arctic zone. Always remember, air pressure is measured in units of millibars. For this, an instrument called barometer is used. The air pressure at the Earth's surface is measured with this instrument. I forgot to tell you one thing. This can you tell you can take students a Xerox copy and stuck in your notebook and write answers of these questions. Okay, give it a try. Study the temperature distribution map given in your standard 6 textbook and the pressure distribution map in this lesson to find the correlation between air temperature and air pressure. Look for me elsewhere. Class 3 environmental studies, class 7 science. Okay, do you know all things in and on the earth stay earthbound because of earth's gravity? This includes air, which is in the gaseous form due to the earth's gravity. Air is pulled to the earth's surface. That is why air pressure maximum at sea level. Note that air exerts pressure on everything and everyone, including us. It is believed that the weight of the air column and on any one person's head amounts to 1000 kg. Thank you very much. Like and share my channel on Academy.